Welcome to Ask and Learn.
So this is our function, and we're already given a domain. And so if we get our intercepts, if we set x equal to 0, we see that we have an intercept at 0, radical 3. And if we set y equal to 0 and we solve, we have an intercept at every 2 pi over 3 plus 2 pi n, where n is an integer, 0, and 5 pi over 3 plus 2 pi n, 0. Alright, let's make it a little smaller so we can fit everything. For our symmetry, there is none. Asymptotes, there's none. And now we can do the first derivative test. So y prime equals cosine x minus radical 3 sine x. If we set that equal to 0 and solve for our critical points, we have x equals pi over 6 plus pi n. N is an integer. Okay, and now if we do the first derivative test, so this is f prime, and we're testing values around that pi over 6, we see that it's increasing to the left and decreasing to the right. And also, just so we know, if we plug in pi over 6 into our original function, we can get the y value at our critical point, which is 2. So that's where we know since it's increasing to decreasing, that's how we know where our max is. It's at 2. Okay, so this is our first derivative test. And now we can do our second derivative test. So y double prime, this is for concavity. So our second derivative is negative sine x minus radical 3 cosine x. Set that equal to 0 and solve. We have x equals 2 pi over 3 plus pi n. Okay, so let's just look at 2 pi over 3 and test values smaller than, which will give us, this is f double prime, so we're testing into our second derivative. F double, let me write that better. F double prime. Okay, so smaller than 2 pi over 3 is going to give us concave down, and if it's bigger, it's going to be concave up. So this is an inflection point, so a change in concavity at 2 pi over 3 plus pi n. We just showed for one. Okay, and now we can graph with what we have. So since we're graphing from negative 2 pi to 2 pi, let's label this as negative 2 pi. Let's label this as pi, negative pi, and then this would be pi, and about here is 2 pi. Okay, and now we have an intercept at 0, radical 3. So let's say this is 1, this is 2, and we know that radical 2 is about 1.7, so it's going to be about here, give or take. Next we have intercepts at 2 pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. So about 2 pi over 3 would be about right here. This is just a rough sketch. And 5 pi over 3 would be about here. And then let's do the same for the other side. It's going to be about here or so, and here, give or take. Okay, and now we're going to show that it's going to be concave up but then it switches to concave. It's going to be increasing and then decreasing around pi over 6. So if we know that pi over 6 is somewhere around here, pi over 6, 2 is our max, remember? So pi over 6, 2, we have a max about here, and it's going to be increasing and then decreasing, okay, until we get to our other pi over 6 value. So it's going to be increasing, and then it's going to decrease. It's going to decrease and hit our next intercept, and then it's going to, let's say this is -1, and this is -2. It's going to go down, and it's going to be concave down, and it's going to be concave down, and then go back to concave up after it hits 2 pi over 3. So let's see where our inflection point is, which is right here. So this is our inflection point. It's concave down, and then it's going to be concave up until it hits our minimum value, which is at 2. And then it's going to come back up, and it's going to hit 5 pi over 3, and then it's going to go back to concave down and continue on. All right, and now let's do the other side. It's going to go down, hit our axis. It's going to start to come back up, but this is the lowest point it can be, -2 as a y value. And then it's going to come back up, and it won't hit the x-axis until about here. And then it's going to go up until about 2, and then go back down eventually. This is our graph, rough sketch.